Today, I'm going to talk about how emergent properties aren't real. Welcome to Missing the Mark, where we look for meaning in strange places. I'm Christopher. Okay, so it's a slightly clickbaity way of describing what I'm going to do, but I'm going to make it good. That said, there are actually several things that are meant by emergent properties. And one of the things meant by emergent properties are properties that are contained in a thing that a human being is doing, which the human being did not realize was contained within it, and only discovers through the execution that that this actually has a property that they come to see in it. But the thing is, the property was in it. So, like the Sierpinski triangle, for example, which is the thing where you start with a point and then there's some rules how you make the next row based on the previous row. And what ends up happening from this, if you follow these rules, is you end up getting this sort of large triangle with all of these inverted triangular shaped holes in it that get bigger and bigger as the thing comes out. And so based upon the simple rules, and I forget exactly what the definition of a Sierpinski triangle are, you get this really interesting looking pattern from this simple set of rules, and you didn't realize that this pattern would produce this thing. So all of the small little triangle holes that are made up in the Sierpinski triangle are an emergent property of the definition of Sierpinski triangle. But all that's saying is that you didn't realize that these rules had this property, that if you were to graph the thing in a particular way, that it would have this overall pattern to it. But that was not something that was added. Nothing new was made by this. The moment you actually have this definition, it contains this result. It's just you don't know about it. Now, so that emergent there's a real thing called an emergent property in that sense. But a sort of more common word for this is accident, as in you didn't intend it. It's a thing that happened that you weren't planning on. Emergent properties is just kind of a fancy way of saying accident. In this sense of emergent properties is just saying accident. And so people then, I've seen this done directly from the Sierpinski triangle actually, but from other things as well, try to draw an analogy to other things not done by human beings, and say like, oh, they just have emergent properties too. But the problem that comes up from this, and where we're going with this, by the way, is whether or not composite entities are real. Because all composite entities can be an emergent property of the interactions of subatomic particles, or they can be real. By the way, I also want to mention another term for emergent properties, and this will open up a lot more discussion of the thing, because emergent properties is a fairly recent term, is epiphenomenon. Epiphenomenon, or the plural epiphenomena, meaning like things that happen on the surface, is how people have talked about this concept for hundreds of years. So emergent property sort of gives it the veneer of being this like new discovery, that here's this idea that people hadn't thought of before that explains things, and so we can throw out all of the philosophy that came before because we have this new concept that none of them dealt with, and so they're no longer valid and we need all new philosophy. And people have been talking about this basically going back to the Greeks, just not in the same terminology. So when you learn how to translate it, you can then see how this sort of stuff would get described and get discussed. And the particularly modern aspect to it is it gets done with a lot more hand-waving these days. Things like the Sierpinski triangle, like, look, okay, I've got these few rules, and then we use a computer program to generate this stuff out, and like, look at the complexity, see? It's all complex. Emergent properties. Bow down before the emergent properties and cease your thinking. Emergent properties. That's fairly new. Not that nobody ever waved their hands in the last 2,500 years, but roughly speaking, that element of it, computers have really helped to give us a lot more high-resolution hand-waving in this sort of way. There's a lot, modern mathematics has made it a little bit easier to wave your hands with great precision and to wave an awful lot of hands simultaneously. That's most of what that consists of. People have asked for a very long time, because everybody's known that the human body is made of parts. This is not anything new. The idea that there's multiple parts of the human body is as simple as knowing that you can say, cut off your hand, and then it's not there. Or it could be attached, and then it is there. Hey, look, we've got parts. Your teeth aren't your feet. Parts. Yes, people have known that we're composite entities since as far back as people have known anything whatsoever. That's not a new discovery. The idea that now we know about molecules and atoms, so this changes everything. It changes nothing. It changes nothing whatsoever, actually. Not in a philosophical sense. It changes some things in terms of what is your actual understanding of the nature of the particular substances involved. That changes. You are able to look smaller, etc., and get a different idea of what they are. If you're talking about the particulars, it certainly changes the way you're going to engineer things. It changes the sorts of chemistry you're going to try to do. But people did things like take rocks and heat them up really hot and get metal out of it, which is a chemical reaction. People have been doing chemistry forever, since the Bronze Age. And, even before that, people would, burn the ends of sticks to make them harder. People have been doing chemistry forever. Advances in this stuff change the particular chemistry that you're doing. It doesn't change the philosophy of the thing at all. It's the sort of important thing to remember. So, and the reason, by the way, why you find that modern people desperately want to throw out all of, wave their hands really fast and explain why you throw out all of philosophy because the new discoveries mean it, is because philosophy is hard, and because it's a lot easier to do the sort of nonsense that they want to do if nobody... basically, if you're dealing with completely uneducated people, it's easier to pull the wool over their eyes, and so they want to try to convince everybody to not read anything, do not become educated in any way, ostensibly because all of that is now superfluous. So you don't need to read it. It's all wrong, so don't read any of it. But in reality, it's if you read it, then you wouldn't listen to these people. So that's really what's going on. And how much do they exactly mean this? I'm not sure, but on some level, I think they actually do get it, which is why they never understand it themselves. They just say it's been debunked and can never even point to any sort of detailed debunking that clearly understands the original source material. It's part of the problem, of course, is if you, to verify that a thing has actually been debunked, you need to know what it is. So we'd have to first clearly understand it in order to then clearly understand the refutation of it. And the problem with things like philosophy, Greek philosophy, like say Aristotle and Plato, is if you clearly understand them, at that point the game's over, and they, the modern charlatans lose all their power. So that's sort of a brief overview of how to spot that you're being conned, because that's most of what's going on in this sort of thing. I'm going to address the rest of it, but that's if you can spot when you're being conned, you basically probably don't really need the rest of this video. Anyway, so to get back to it on emergent properties and composite entities. The thing about the emergent properties when it's applied to things that are not the intention of human beings is that there's no direct analogy here. The only way you could actually have any kind of direct analogy to be meaning something related to the original words here would be essentially if you were to say, you could be a deist. You could say that there is a creator God, but not like the one described in, not the one, that's described in natural theology, such as the argument from motion or the argument from contingency and necessity and so on. Rather, essentially, like some sort of like really powerful but not overly intelligent being that is capable of doing things but doesn't know what the consequences of his actions are going to be. And so, running like a giant experiment. This is, I think, by the way, why the whole simulation hypothesis is so popular, because basically deism is incoherent, and this is a way of giving you... Because deism tries to pretend that it's compatible with natural theology, but it isn't. I'm sorry, when I say deism, what I mean is like the blind clockmaker type deism. That type of deism is not compatible with natural theology, and so it kind of pretends to be. The simulation hypothesis is a lot more. It is compatible with natural theology because it straight up is saying like God didn't make the world. In a sense, this is basically like a retread of Gnosticism, where the world was created by some fallen creature. In the original Gnostic idea, you have the demiurge, which was depending on which Gnostic you asked, but one of the aeons in the Pleroma, was it Sophia? Or no, I don't think it was Sophia. I can't remember which aeon in the Pleroma, because you had Gnosticism, again, it varied with who. You have God, and then you have like a bunch of like lowercase g gods, roughly speaking, but they're all perfect-ish, and these form the Pleroma, from the Greek word for fullness. And the individual members of this were the aeons. And then one of them developed a passion, and which was an imperfection. And so then she threw it off, and that was the demiurge. And the demiurge then, which was not God, but could kind of see this. It was imperfect, and was in pain and unhappy, etc. And so it tried to, and it disliked being rejected by everything because of its imperfections, because the aeons and the Pleroma are all perfect, even though one of them was imperfect. The whole perfect thing can only perfect thing can perfect thing would only generate perfect things, so it has to be something imperfect to make our imperfect world. You can't bridge that gap between just kicking the can down the road a little bit isn't going to get you all the way back to how did God, through an aeon that was perfect, create an imperfect thing, because that perfect aeon would have to still create perfect things if perfect things can only create perfect things. Anyway, I'm sorry, this is not a video about Gnosticism. I just want to point out that the simulation hypothesis is basically a Gnosticism with a technological veneer, that like instead of aeons and a Pleroma and a passion with a demiurge that created the world, trying but failing to imitate the real God and trying to be God for its creation, what you have is, instead of the demiurge, you just have some like super advanced aliens who are doing a computer simulation. And so it's the same basic idea that you have here. Like the super advanced aliens would be somehow came about in some sort of better world than the one we live in, but then they created us through their simulation, possibly to see what's going on. Okay, so if you go through something like that, you could then have an emergent property, in the same sense that like the term originally gets defined as things that came about, things that are contained within the original, but that you didn't realize were going to be contained within the original. And so you can have that if you go with something like the simulation hypothesis, because then you can have this imperfect creator that doesn't know what he's doing, who gets surprised by the result of what he's doing. And so he could be just trying to simulate a bunch of subatomic particles, and then like out pops these complex patterns, and it's like, wow, that reminds me, that hairless ape thing reminds me of us. I mean, bunch fewer arms, nowhere near as many eyes, speaks a strange language, but it kind of reminds me of us. Wow, who knew that, when you did this, you'd get that kind of result. Okay, you could have that. But you just have to ask yourself, like, is Gnosticism true? And again, I've talked about the simulation hypothesis a whole bunch. It doesn't work. There's no way to make the simulation hypothesis work. There are different forms of it. The TL semicolon DW, too long, didn't watch, of the original one, basically is like you either like if it's at the subatomic level, then the problem is in the container universe, their computer obviously would be so large it would just form a black hole. Then you have to say like, oh well, maybe their physics is completely different, in which case like you're just inventing something that you have precisely zero evidence for in order to get around a problem, and a hypothesis for which you have zero reason to believe is not really a very good answer to the problem of your original idea is impossible. It's not a good idea to rescue something that can't work with something that you have absolutely no reason to believe is true. Anyway, and then the other one, the more like more like a Matrix style, video game style thing, is also, at that point, I addressed that in the other video. In any event, you don't get emergent properties out of that one because everything's fake and you don't have emergent properties. That style, everything's a video game, is somebody had to code up like all of the pretend computers and pretend bookshelves and pretend hamburgers and pretend everything, because they didn't simulate it at the subatomic level at all because they didn't have the computer resources to do so, because like the number of calculations to do quantum mechanically to just do like a protein folding is so ludicrously beyond the computing power of the world. And when I say ludicrously beyond, I mean like, we couldn't finish it in 1 trillion years. Anyway, we couldn't finish like one iteration, like finding out what hope happens like a moment later in 1 trillion years. The calculations are so intense. Anyway, so no matter which way you try to get around it, it doesn't work. And it's only relevant in the one particular case anyway, and you can't make it work there either. Anyway, the reason it's popular is for the same reason as Gnosticism, because it gives you certain faux spiritual insights. Anyway, so the thing about the emergent properties is, really fundamentally, actually, this wasn't as much of a digression as I thought. Because now that I say it, I realize that fundamentally emergent properties is really trying to get basically at a sort of neo-Gnosticism. That we're not really in the sort of... Well, actually, there are people who still leave me comments on my video about Gnosticism, talking all about how, like, St. Irenaeus was against the Gnostics, so you can't trust anything that he said. I didn't know there were people who are still in for name brand Gnosticism. Anyway, Gnosticism brands secret knowledge, to use a very modern kind of terminology. But anyway, so there are people, but a lot of people, I think, have a basic attraction to the sort of thing that Gnosticism was, but for various reasons, like, it just doesn't look right. For the same reason that science fiction is just fantasy in which you have military uniforms without buttons. And it's like, look, you still have magic, your warp drives and all the rest of it. It's all magic. Like, all of these things are it's the same thing as fantasy. It's just in fantasy you dress in robes, and in science fiction, you have a lot of metal and carpeting, and you have military uniforms, but they never with buttons down the middle like modern military uniforms. They're all futuristic because they don't have buttons. That's the real difference. I think there's a reason why it is more palatable in a certain way. It looks more connected to ordinary experience, basically. And that's the thing. The distinction between science fiction and fantasy is basically, fantasy is specifically trying to distance itself from ordinary experience, whereas science fiction is specifically trying to evoke a connection to ordinary experience. Anyhow, that thing that trying to evoke the connection to ordinary experience is why, like, you get things like the simulation hypothesis, which is a modern Gnosticism, which is sorry, it's snowing outside. I'm distracted by that. Anyway, is why you get that connection to the modern Gnosticism of it looks more connected to say it's a computer simulation than to say that, like, there are aeons in a pleroma. It's the same basic idea, and the same sort of thing about, like, that whoever made us is surprised by what happened, didn't anticipate it, and so on. So, it's our... Sorry, I didn't mean to hit the microphone. Our imperfections come from the imperfections of not of our ancestors, but of our maker, because we don't want to take the idea of original sin seriously, because that means we're taking the idea of the intermediation of creation of other human beings seriously. And so the world gets way too big to fit inside of our heads. Not as much of a digression as you think, by the way. So when we come to emergent properties in the way it tends to get used, like, there's nobody who meant anything. And so, like, all of these things just have these things that are going on for no reason, with no intentionality behind them. There's no reality that these things are partaking in. These things do not have any sort of reality given to them. They're just kind of there and are accidentally making the stuff that's going on. even though there's nothing that actually holds them together into the same reality. This is one of the fundamental problems, incidentally, with like modern styles of atheism, which are basically all of them. Anyway, the problem is that it's positing that you have all of these entities in a shared reality with each other, but without anything binding them together. And that's why people who actually try to think this through tend to devolve into some sort of pantheism, that actually the universe is all just one thing, the separation between entities, the distinction between subatomic particles, it's not real. You can see this to some degree in the effort to find symmetry breaking, where there aren't actually distinct things, it's all just one thing that that somehow, like, it's the same thing, but with this distinction, and then again each one branches off again, and so instead of there being distinct, these four distinct things, they're actually two, and those two are actually one thing. It's just one thing. Just ignore the fact that actually clearly there are distinct things that are different from each other. It's all just one thing somehow. There's just one solitary generating thing that just accidentally thinks of itself as multiple things. You see this kind of pantheism crop up, and that's what this tends to devolve into, because the fundamental problem with the kind of atheism that calls for emergent properties, where you have nobody who, and therefore anything that happens is an accident, in a sense. The world is a joke that no one told, it's an accident that no one made. Okay, fine. The problem with all of these things is you have all of these distinct entities, proton 1, proton 2, proton 3, proton 4. These things which are distinct, they can exist independently of each other, but for some reason these things are interacting with each other, despite the fact that there is no one to bind them together. They're all in space, but that space did not create the protons. Again, that's why you actually will see some people who really, really want there to be some sort of theory, like, actually space does generate it. Like, there isn't actually particles, it's just that the field, the uniform field became non-uniform, but it all balances out, so there isn't really anything. Like, there's just as much negative energy as positive energy, so it all cancels to zero. There's as much negative matter as positive matter. There's negative gravity and positive gravity, so don't worry, there isn't actually anything here. It all sums up to zero. It's just that for the moment, somehow this nothing somehow is like stuff, but not really. Not really. Definitely not really. And so that's why you get there, and it's always some form of that. You get basically the emergent property thing. It always has more or less this fundamental problem of holding that the universe is a joke that no one told, a joke with no punchline that nobody's told. But somehow it's here, and you always get the problem of how do you have multiple things that interact with each other that don't have anything outside of them? Because at the heart of it, what's going on, the thing that motivates this emergent properties talk, is trying to explain how there is nothing but the stuff. There's nothing but the stuff. There isn't anything outside of them. There's nothing that unites these things together. And fundamentally, by the way, and I want to say, like, this does get into the realm, because this would, of course, deny human reason. You can't possibly hold, human reason only works if the world is rational. If the world isn't rational, then there's absolutely no way that it would conform to human reason. So human reason cannot actually be a true reflection of reality, which is why everybody always comes to that conclusion eventually, who goes down this kind of path. They always say that human reason doesn't actually understand the world. Okay. And you can look it up, whether you're talking about Buddhism or Hinduism or whatever, the various Greek philosophies that denied this, because you can find everything except Christianity in ancient Greek philosophies. They all eventually denied human reason, because they all have to deny human reason, because the only way that human reason can work is if the world is created according to a rational mind, that our mind can be a reflection of or an image of, can partake in some fashion, such that the structure of the world matches. If you don't have that, if there is no structure to the world, then the world can't be rationally intelligible to the human mind. That's not to say that you can't be clever, and this is why we always degenerate into why we're the cleverest, the general atheist position being that we're merely the cleverest of the beasts that crawl the earth. And that's why, if you ever look, science always devolves, when these atheists are talking about it, into engineering. It's simply that there are some things that we can interact with in a predictable manner and therefore can control. And so this is, as far as it goes, there are things that we can control, and that's it. We can't understand it. Reason doesn't really work. But if we kind of apply this approach, it seems to work for at least some things, so we'll push it as far as it can go. That's the Enlightenment in a nutshell. Anyway, the point here is that, fundamentally speaking, this is a choice. You can choose to hold that the world is meaningful, or you can choose to hold that the world has no meaning in it whatsoever. And if you choose that the world, because the thing is, you cannot rationally prove that reason works. It would be circular. You cannot have a logical proof that logic is true, because, well, you're presupposing your conclusion in doing this. This is why, fundamentally, this orientation to the world, is the world real, or is it an illusion? Is there such thing as, does reason work? Is there such thing as meaning, or is it all a chaotic stream? Is it a chaotic, irrational thing that we cannot understand, and we can, to some degree, cope with as best we can until we die, and that's about it? Which of these two things are we in? Well, you can't have a rational argument that says we're in the one and not the other, because that's already presupposing we're in the one and not the other. It is fundamentally a choice. It is fundamentally... Now, I don't mean, I want to be very clear here, that you can just, pick on the basis of, like, whatever you feel like, or pick on the basis of your hopes, dreams, or aspirations, pick on the basis of what's more comfortable. That's not what I mean. What I mean is, fundamentally, you have to look at the world and then come to a decision about, what is it? What do I see? What is this thing that I'm in that's outside of me and includes me? What is it? Is it rational or is it not? And you have to answer that question. Once you answer that question, all sorts of things get shut off, and the whole reason for having this emergent properties thing gets shut off if you believe the world is, in fact, rationally intelligible. If you believe that reason can get at truth, then you don't need to bother yourself with the whole emergent property thing, because you no longer need to explain the sort of things that it's there to explain. You no longer need to explain away the sort of things that it's there to explain away. And so, I mean, basically, and this is the thing, because emergent properties are always trying to explain something away. To say that something is an emergent property is merely to say that it is an accident, is to say that there is no intentionality in it. And that kind of negative is not really something you can disprove other than by pointing to the intentionality that actually is in it. In the same way that the way you disprove that there is no such thing as a cow is by pointing to a cow. You can't really disprove the non-existence of cows on its own apart from the existence of cows. And so, that's... I'm not making the silly statement, by the way, about how you can't disprove a negative. The point is that you can't... That the contradiction of a negative is a positive, and you can't really prove the contradiction of a negative without reference to that positive, because they're the same thing. So, like, the way you disprove that there is no such thing as the Pacific Ocean is by pointing to the Pacific Ocean. You can't point to the problems in the non-existence of the Pacific Ocean, but not in any way be referencing the Pacific Ocean itself. In like manner, the thing about emergent properties, since emergent properties is actually, properly speaking, simply the denial of the intentionality behind the property, is that you can only point to the intentionality behind the property. And for anything that exists, you can always say it doesn't. I can say the video camera that's filming me right now does not exist. I can say you, the viewer, doesn't exist. I can do it. There's a great line in The Importance of Being Earnest, where somebody asked him if he denied that his name was John. Do you deny your name is John? I could deny it if I wished. I could deny anything if I wished. But I don't. It has been John. But it is John and has been John for a long time or whatever. I forget the exact line. Sorry. Would have been better if I had remembered that properly. But, it gets to it. Like, you can deny anything. It's doable. You can do it. And that's fundamentally what saying that something is an emergent property is. Like, is there any difference? And by the way, emergent properties are just a veneer on the, since they're just saying that there's an accident, they're just a veneer on top of the improbability of accident for explaining a thing. Like, what they're trying, because fundamentally, you see a painting, detailed painting that's a painting of, say, George Washington, and you can say that's not a painting. It's actually a whole, by a weird set of coincidences, the wind blew cotton fluff into this thing that looks like a canvas, and then there are like all these pigments that just happen to like fall down in the right way and adhere, and then there's a splash of varnish on top, etc. And this isn't a painting. It doesn't represent anything. There was no intentionality behind it. It just happens to look like a painting of George Washington. And nobody will take you seriously. But if you then say like, oh, there's this natural process which has the emergent property of happening to bandy particles around, and the particles tend to interact with each other in such a way that they come out like portraits some of the time. And so it's just normal to see like, a portrait. That's just sort of inevitably what's going to happen. If you have wind and cotton and pigments, you're going to get portrait looking things from time to time. It's just one of those things that'll happen because it's an emergent property of the simple forces that go together to create it. And how can you tell that that's the case? Well, you can see the thing right here. I'll give you a theory whereby stuff gets blown around until it coheres in shapes. And this is one of the shapes that it coheres in. And then, incidentally, like if you ever look into the whole like emergent properties in particular, they don't actually get better than that. There's always massive quantities of hand waving involved. You have to look into the specifics of the specific claims in all cases to say that like there's no intentionality. It naturally produces things of this form. You need to like look specifically into like why would it naturally produce things of this form? Why will you get it? And especially because like you don't actually get it, repetitively and so on. Anyway, the point is, if you actually do the massive amount of work of looking into the details, which I highly recommend actually doing, because like generally speaking, the best way to deal with any of these things is hundreds of hours of study of the details. It's much harder to be fooled by hand-waving arguments about things if you've done hundreds of hours of research into the particulars, like really like study the particulars of whatever it is, like whichever particular, but like whether you're looking at the theories of planetary formation or whether you're looking at theories of evolution, like actually study the evolutionary history of large chains of various kinds of animals and like learn in detail everything we know about like the various ancestors. Look at what are the actual what are the actual fossils that this stuff is based on. It's always funny when it turns out to be like, we know about this species because of like this fraction of its jaw. It's like, oh, painting had all sorts of interesting detail, and like what we actually have is like this much of a jaw, which looks like the jaw of some other relative which we have more of, and so like, oh, it would be this big on the basis of calculating the different size of the jaws. And that's not all fossils. I'm just saying it's funny when you come across that because it gives you an interesting perspective and you realize like, oh, we've got like hundreds of Tyrannosaurus Rex fossils, and we have like 1,000th of a fossil of this thing, Caprasuchus, which I remember from playing the game Ark, the boar-headed crocodile. All we have is a skull, and so like in Ark they made the back legs much longer than the front legs, and like who knows, maybe it could be true. No one's got any reason to believe it's that way or any different because literally no one's ever seen a leg from a Caprasuchus at all. Anyway, spend a very, very long time looking into all of the particulars of this stuff, and you will be in a much better place to evaluate this kind of stuff, and it'll be a lot less impressive to you. And especially for anyone who's young, that's a very, very important thing. Do a ton of studying of the specifics. If you are in any way bothered by any claims, especially scientific claims, go study the science. Go study it thoroughly. Go study it, learn, if it's mathematically based, do your best to learn the math that's involved. Look up the actual experiments that are involved. Look up the actual data. Like thoroughly learn the specifics of it. There is no better way of demystifying anything than by like learning the specifics of it. So that's one of the biggest pieces of advice I can give you right there, is if it gives you trouble, do a ton of studying of the specifics of it. One of the things that you will find is any atheists who are waving their hands at you and telling you about what science proves or disproves, there's in my experience, there's a 99.99% chance they know very, very, very little of any of the specifics of anything involved. The degree to which modern atheists on the internet who will talk about the conclusions of science know about its actual conclusions, the experiments involved, the actual data involved, to a first approximation, none of them do. They're few. They're rare. They're quite rare. So I really recommend, and it makes sense the atheists would be lazy, right? Because why shouldn't they be lazy? They can't come up with a rational argument for it. They're just emergent phenomena. None of this is real. So you can't possibly have an emergent argument for why you have a moral imperative to not be lazy. But if you're not, well, don't be lazy, because you were made by God with energy in order to spend that energy and the ability to learn in order to actually go and do that learning. So, actually get out there and do that learning. That's the single biggest thing that will help you is hundreds of hours of in-depth study of the natural world and everything that is actually known. Like what are the real experiments? What is the real data? Look into that stuff. That will help you more than general arguments about it will in practice, because you'll actually know what's going on, what its limitations are, and how far it goes. And also, it's good to know God made that world, so find out about it. Very good to do too. So, ultimately, that's the thing about emergent properties, is emergent properties are just claiming that are simply consist entirely of the claim that there is no meaning. They're a kind of fancy way of claiming that there's no meaning. They are a hand-waving way of claiming that there is no meaning, but they are not different in category. They're not fundamentally different in any way from any other claim of there not being any meaning. There's no difference between an emergent property and an accident. They're the same thing. And the claim that the particulars are simply contained in the originals is something that if you look into, okay, how does it work? How does physics result in pigs? Specifically speaking here, not hand-waving, physics produces the conditions that make pigs. That's just hand-waving. Specifically. And then when you get into the specifics, you'll find they're not there. No one knows. And by the way, just to forewarn you, because especially if you're young, it gets a little intimidating. You tend to get these answers like, oh, well, if you can prove the opposite, then why don't you go apply for your Nobel Prize? It's like, well, I'm pretty sure you would not accept that argument for anything. Kind of curious that you're making it now. Comes up in a lot of stuff, like how do you know that the charge of an electron, when you experimentally determine a charge of electron in a high energy electron beam, right? Or the charge of an electron in, let's say you're using the oil drop experiment, right? So when you do all the work, you have the charged oil drops, and you let them fall and then reestablish the charge and so on, and then calculate out their charge, then look and find the that's a multiple of some, all the charges are multiples of some some unit fraction. Like, okay, suppose suppose it's all valid, suppose that there's no experimental error, etc., or the experimental error is sufficiently low, yada yada. Okay, how do you know that that's the same charge as the electron, say, like when it's in a neuron in a human brain? You can't possibly perform this experiment in a neuron being used in a human brain consciously thinking. So how do you know? How do you know that charge isn't only the charge of when it's in a scientific experiment, like when the electron's asleep or at rest? How do you know that electrons don't have other states where their properties are different? And the answer is you can't. It's impossible to know this because you can only conduct laboratory experiments in a laboratory. You can't conduct laboratory experiments in something that isn't a laboratory that's being used for other purposes. The moment you're even trying to impose an electric field on an electron that's being used inside of a nerve cell inside of a thinking human brain, you're disturbing it from being part of that human brain, and so it's literally it's literally not possible to perform the kind of experiment that would be needed to determine this. And so when you just point out this like little philosophical curiosity that it's impossible to actually know whether or not laboratory experiments can be generalized outside of the laboratory, because nobody counts the number of electrons and multiplies out the charge to come up with anything. That's not a thing. It's not the way it's done. Subatomic physics, by the way, has a very curious disconnect between like the things that people actually do and stuff like engineering. When you learn how you do the engineering, you learn how you do the subatomic physics. There's kind of the fact that like all the stuff people actually use in engineering for the most part was all developed before the subatomic physics, and then there's stuff in material science, but the really, really, really short version is that none of it works well enough that you don't have to do experiments and find out the actual results of it. So, like, the degree to which, like, oh, it's experimentally verified by engineering, it actually isn't. If you, again, look into all the specifics of engineering and so on, look into the specifics, like, really learn all this stuff. It really is quite valuable to know it in particular. It's also very interesting. Okay, I'm a nerd, but it's still generally interesting, even if I'm more interested in it than most will be. Anyhow, the point there is that when you look into the specifics of that stuff, of like how are these emergent properties actually supposed to work, what you'll find out is they're all just so stories. It's like, well, it could be, or like they'll say, oh, the reason I brought that up is that the only counter argument I've ever heard to this when I point this out to atheists is like either A, that's ridiculous, and when I point out that it's not ridiculous and it's literally impossible to find out, the answer is, generally some version of like, okay, well, go prove that it's not the same, and like, you'll get like all the Nobel Prizes, so why don't you go do that and prove it, which is an impressive case of point missing. But moreover, it's exactly the sort of argument they will never admit of. No one will ever, you'll never find an atheist who accepts like, okay, just go, if you could disprove that God exists, then like, you'll be quite celebrated. So go ahead and go disprove it. Otherwise, like, you just have to assume God exists. They'll never accept that argument for good reason. It's a stupid argument. But they'll use it, which itself is instructive, incidentally. I've been talking to atheists for, 25 years or so. I've seen a lot. Anyway, the thing about this, and sort of to wrap it up, is that the thing about emergent properties is they're a non-explanation. They're just saying, they're basically a hand-waving way of saying it's an accident, but it's not as big as an accident as you thought. It's not nearly as improbable as you thought it was. And then if you ever ask for the proof that it's not actually as improbable as you thought, the explanation of pure accident, because anything intentional could also happen by accident, just phenomenally improbably, like discussed in the painting. And so ultimately it's just a just so story for how it's not actually as improbable as it seems. And that's what they always boil down to. To really find it out, you will need to do a lot of work into the specifics, but that's kind of the place to go. That's the map of the territory. That's kind of how it works. And I do not mean this as a shortcut for doing all of that work of going and learning about all the things, go and look into the specifics. That's the real way to come to the right conclusions. So learn science, learn engineering. You don't have to learn them. You don't have to become a professional at any of these things. But like, spend a few dozen hours reading books on science. Spend a few dozen hours reading books on engineering. Look up all the things. You can do a lot of very useful work on Wikipedia even. I mean, the page on the oil drop experiment, at least the last time I looked at it, was actually very detailed and very interesting. The experiment on the torsional balance used to measure the gravitational constant. Fascinating, really good page with lots and lots of details in it. So I mean, you can do stuff even there. And I really recommend learn all about scientific experiments. It's really worthwhile. And fundamentally, at the end of the day, if things like emergent properties bother you, that's really the place to go. And to some degree, I think it's probably the case that if emergent properties bother you, that's a really good sign that you're the sort of person who should learn a lot more of the details of this kind of stuff, that you should really study physical sciences and engineering, and how you don't have to get an engineering degree, but like study how are particular things made and what's the history of how these things were developed. If emergent properties bother you, you probably are the sort of person who should be doing all of that. And I think it very likely that the sort of person who shouldn't do that, like they're not made to they're not the kind of, I know about it as a nerd, there may be other kinds of human being that should learn about this stuff, but that they're not the kind of people, that for the people who aren't that kind of nerd, for the sort of people who aren't made to learn, lots and lots of the details of scientific experiments and scientific theories and so on, they're probably not bothered by the idea of emergent properties. So, yeah, ultimately, I'll end there. Go study science and the history of engineering and how things are made and all that stuff if emergent properties bother you, because emergent properties bothering you probably is a sign that you should know more about that stuff than you do. Until next time, may you hit everything you aim at. If you like this video, then clicking the like button, according to YouTube, will make them more likely to recommend it to others. If you know anyone who might get something out of this video, then it would be kind to share it with them, or just share it on social media in general. And if you'd like to see future videos of mine, you can subscribe. And if you're not in the habit of checking your subscriptions page regularly, then I suggest clicking the notification bell and setting that to always, because otherwise subscribing to a channel basically just sort of like gives YouTube a hint that maybe it should consider recommending these videos to you, possibly at some point, if they think so. It's a funny world we live in. God bless.